Hi, thank you all for coming to my talk. This is JavaScript for the rest of us. I want to talk a little bit about some alternative solutions to modern front-end frameworks that help you be a little more productive along the way. So first things first, to know who the rest of us are, to know who I am. My name is Jacob Daddario. I'm a senior software engineer over at a small firm in Grapevine called Vent Technology. We help with accounting automation, and I write Ruby on Rails for an internal tool for the company. If you need any accounting automation services, we're happy to help you. But more importantly, even more importantly, recently married, so there's some lovely pictures. Thank you. Yes, of my friends and beautiful wife. But enough about me. Let's talk about this guy. This is the Shad CN guy. Nameless, faceless. Evidently, he works for Vercel now. His profile image is a cartoon character. Sort of an enigmatic figure. But he is the core maintainer and creator of the Shad CN library. You all have probably heard of it. It is sort of like a web primitive solution for React. Everything you need, readily styled, adjustable and themable with Tailwind CSS, fully accessible, keyboard navigation. I mean, just look at it. You get this button, you get the fly out, drop down menu, you can go nested in it. Like I said, keyboard, ARIA compliant, the whole 9 yards. Done, right? Like the talk's over. I think this is all we need. But maybe not, because when you reach for that solution and you start going that front-end framework path, you're not quite done when you just start dropping in the components. Now you need to wire up the form. So let's take a closer look at it. You can't submit forms like you can with the normal form implementation when you're using React. So now you got to wire up some state. You have some state management there. You need to wire up a change handler, right? You need to bind the state to the inputs. You have to bind the value to the inputs because the DOM is redrawn every single time. If you just have a standard web page, the inputs can remember what their value is, but not when you're redrawing every single time your state changes. So now you have to bind all that. And you can't submit forms, right? So now you have to write your own submit handler. You have to pull in Axios or write your own API client. You're doing a lot here, and you still don't have things like real-time validation or error handling. So maybe you reach for a different solution, right? This is still a lot of code, but now we've pulled in React hook form. This is a pretty common custom form hook that allows you to ease the process of making forms with React. If we zoom in a little bit, we can see we get some abstractions here. We have this new register method that comes in. We have a special handle submit that we need to implement. But the state's contained in one place. We now have error handling built in. If you look at some of those input tags, you can see us binding them with the register method. You can see us binding them to certain names in the state. You get some validations, like you can require fields. Now we're getting a little more functionality. We've introduced some indirection, but we're most of the way there yet, or now. But are we done? No, because now we need to do some of this, right? This is the Swagger UI. This is how a lot of people document their APIs these days. Because now you have to hit your backend. You haven't even implemented the backend yet, right? And you probably have two different teams. You have a front end and a back end team, so you need to communicate between the two of them. So now you're spinning up this documentation that everyone loves and loves to maintain because you have to do governance, right? What if more people become dependent on your API? Now you have to worry about versioning. And maybe we should have used Fast API. I don't know, that would have auto-generated it. But I've got this new LLM thing that uses JSON schema and generates. It's great, guys, it's great. And now you're doing this, right? You're in kind of like Zoom purgatory with these horrifying AI-generated faces. They're all frowning. The buttons are in the wrong place. And you need to ask 3 people where the contact form is. It was a contact form. Didn't we know how to do this? Isn't there a better solution? Well, the Rails ecosystem thinks so, and they've tried for a long time, but I think they finally landed on a good solution. And that solution is called Hotwire. It's a suite of 3 libraries. Today we're going to talk about 2. The 3 libraries are called Turbo, Stimulus, and Turbo Native. We're not going to discuss Turbo Native today. One of the questions you may already have is like, hey man, if you're not using an API, how do you do mobile applications? Turbo Native is the solution to that problem. It uses web views and allows you to layer on first-class like iOS and Android primitives over top of it to get that kind of like native experience. We're not going to focus on that today. I'm happy to talk about it with you if you'd like to, though. But first, we're going to talk about Turbo. Can we simplify page navigation? right? Can we get that SPA feel without having to introduce like a specialized router? Can I just visit pages and have it not be kind of bad? So the first part we're going to talk about is Turbo Drive, and we're going to take a closer look at these two videos here in a second. Turbo Drive replaces the way that page navigation works in your application, right? So this is a navigation without Drive. Perfect, beautiful, 2005, the page snaps. You have massive layout shift. The user doesn't know what's happening when the page is loading in, right? We all remember websites like this, mostly. I was 8 in 2005, so I kind of vaguely remember. But we all remember the days of like web pages coming in one chunk at a time. This isn't a good experience. So what does Drive do to solve this problem? Drive does a few things. By the way, all of these requests are artificially slowed down, just so we can see the effect of things. Firstly, with Drive, when you issue a page request, you don't see that page snap. And instead, if the request takes more than 250 milliseconds, you see a loading bar pop in. So you don't have like this effect where you navigate the page and it's slow and you just like jump to a blank white canvas. That's obviously a bad experience. This prevents that and gives them a nice loading animation. The next thing it does is it pulls from a navigation cache. You can disable this because it kind of has some rough edges. It can create some weird UXs if you're not careful. But for demonstration purposes, it's included here. And you can see, I navigate to that page right away and it's still loading, but we actually jump to the new page instantly. And that's because that page was in the navigation cache. And the last thing it does is it just swaps your body in and out, right? That's why there's no layout shift. We're not hurting our Lighthouse score with this because while we're waiting for the thing to load, we get the whole document in, and only when the whole document is in, we swap out the body. And so you get this SPA-like navigation. We have a web app that looks like what users expect in a modern web app without having to create an entire artificial routing layer, right? So next up is Turbo Frames. What do Turbo Frames do? And we'll look a little closer at this video in a second. Turbo Frames do partial page decomposition. Now you may be asking, well, I don't know why I'd want to like decompose my my page into separately navigable elements, and that's a reasonable concern. I have a similar suspicion, but there's one use case that they're really good for, and that's lazy loading. So here I've enabled one of our Hotwire dev tools that shows us where turbo frames are on the page, and that's that sort of cyan dashed outline. And I'm showing what that lazy loading looks like. So what's happening here is this is a little like demo app I built. I'm navigating to an organization show page, but there's a sub-resource that's underneath it, right? It's a list of members. And for whatever reason, let's say it's particularly slow, so I want to lazy load it. How do I do that with Turbo Frames? I create a frame region in the page. And so on first load, that turbo frame just has the skeleton loader. And when it mounts on the page, this custom element initiates a web request to a second endpoint, which returns the remainder of the data. So how does this work? This is the network tab. And don't worry about the specifics. I know it's completely unreadable. I've done the old social media red arrow thing. There's 2 requests kicking off. So on the very left-hand side, you can actually see the initial page load, right? So that's when I'm saying, take me to organization ID 6 or UUID, whatever. And then that's when we see the page snap in and it has that skeleton loader. That's what comes with the first page load. But once that page is loaded, the turbo frame element mounts onto the page and it sees that it has something in its source attribute. That's a key to it, that it's been navigated, and it does that to initiate a lazy loading request. And that's that second request we see there. And so the response that I have included in this image is what we actually get back from the server. This is another full page navigation. We just returned a brand new body. And in that body, we have a turbo frame element with the ID memberships tab. So the way that it works is whenever Turbo gets a response back that has a frame in it, it looks for a frame on the existing page that has a matching ID. And if it does have a matching ID, it just swaps it out. And so that's what happens here, right? And for some reason, Keynote doesn't want to play this if I only go back 1 slide, so that's why I keep going back 2. That's what's happening here. The frame initially has that skeleton loader, it makes the request, it swaps in the new content, which is the data the user actually wants to see. And we've still written 0 lines of JavaScript. This is all built into the application. All I had to do was build my Ruby on Rails app or any app, Turbo and Stimulus, and the whole Hotwire stack is framework agnostic. All I did was build my web application like we did in 2005, and I got this sort of like smooth page transition. I got lazy loading, the sort of stuff that we associate with modern web apps for 0 lines of JavaScript. So next we have Turbo Streams. We'll look closer at this demo right here. What's happening? So I'm in a authentication page, and I'm typing in the credentials for a test user. And then when I go ahead and submit it, something curious happens. I get a modal that says, hey, your user's not confirmed. Click this button to resend the email or hit OK to close it. Well, that's kind of strange if you think about it, right? Because that's not a page navigation, right? I'm actually making a modal appear. That seems like JavaScript to me. And that doesn't make sense because in order to know that a user isn't confirmed, we need to phone home to the server. What's happening? How am I triggering this? It's server trigger JavaScript. So what happens whenever you make a stream request is you get an HTML document back. In this case, it's another custom element that comes with Turbo called a Turbo Stream. That Turbo Stream has 2 things on it. It has an action, which tells Turbo which pre-canned JavaScript action it wants to take, and it has the data necessary to execute that action. So in this case, we can see it says action append, so we're adding something, and then the other data that's needed is a target. So the target in this case is telling it, go find an element with ID root, and then it uses the template tag that it ships to take everything in that template tag and append it to the root element that we've targeted. And so in this circumstance, what I'm doing is I've created a modal component, right, just with vanilla JavaScript, that I'm appending in the open state to the root element. And that's taking on and creating a portal like we would in React, locking scroll, hijacking focus. And so you have that sort of like portal-esque experience without needing to write any JavaScript. Again, this is pre-canned. Now, some of you may be familiar with the Ruby on Rails ecosystem. If you are, I want to clarify something. Streams are not this. If you know what this is the old Rails UJS technique, coming from an era of CoffeeScript in like 2013. You know, it was pretty poor timing. Like a lot of the Rails JavaScript tooling came out right before Facebook launched React and like massively changed the way we did things. Angular was gaining in popularity too, but my understanding is React was much more popular. So they did this unobtrusive JavaScript stuff. What this was pretty crazy. What it was is you would have a .js.erb template, and if you responded with this, it would literally inject it into a script tag on your page to execute. Now that's super dangerous, which is why they don't do it anymore. Basically, all modern content security policies don't allow you to do that. Executing unvetted content in a script tag is bad practice. So we no longer do this. This is not this. Trying to introduce metaprogramming into a place it doesn't belong, the land of untrusted input, was probably a bad idea. So streams are not that. They're pre-canned actions. There's 7 actions that come standard, so that JavaScript is never changing. It's always trusted and safe. It's just the stream element that you submit sort of as an argument that changes the behavior. And we have still written 0 custom lines of JavaScript. I have not had to open a .js file to do any of this. But sometimes you need to write JavaScript. So well, what do you do in that circumstance, right? That's what you use Stimulus for. You organize your JavaScript with Stimulus. It's all vanilla JS. There's no virtual DOM. There's no custom domain languages. But it's a way to organize that vanilla JS that makes things a little more sane. So let's look at the problem. This is an example of like an old jQuery file that you would find in many static sites and Ruby on Rails applications circa like 2015. And there's a couple problems with there. One, state management is like a disaster. You can see here at the top, that's how you store your state. You just open an object, you start checking stuff in it. You can do things with data attributes too, but those pose their own problems, because if you start putting things in data attributes, you have to figure out like which elements are holding which state. Another thing is selecting elements is fragile and unorganized, right? You just kind of have to begin every single thing either with like a jQuery lookup or find query selector, which has its own quirks if you want to stay away from jQuery. Similarly, like a lot of this stuff is cached. So what happens if I start introducing new elements into the page? How do I like worry about refreshing that? And then finally, you end up with this event listener chaos, right? Especially if you're not very good about splitting your JavaScript assets You may, like, on every request, be trying to select things that don't exist. And like, what if you're using too general of a selector? In this case, this thing's trying to select on dot button. That's really generic. You can get yourself into all kinds of weird circumstances. And finally, like, there's no opinionated way offered on how to factor this code, right? So that's why you usually end up with these giant, crazy jQuery files, because no one is given a good guide on how to put those in their own and proper place. These are the problems that Stimulus solves. So let's look at this. This is the outline of a controller, and you can see a few things. So there's some static definitions at the top, and we'll talk about those in a moment. And then just a set of methods. I know we're using the JavaScript class structure, which people don't love, but as a Ruby developer, I love OOP, so it feels natural to me. And what this does is it provides also a reasonable place for you to factor your code into. In this case, this is a list box controller, right? List box are those fancy styled selects that don't use the OS native like select input. So this is what I use to implement a list box in that demo application. And everything for that list box is contained here. There is a natural place to factor that code into. So let's talk about the parts of it. First, we have the values API. So you see I have a static definition for values. It's an object that declares the different values in it and their types. And it puts all the state for that piece of code in one place. And it gives you accessors on the class itself. And it also allows you to do things like write callbacks, right? So you could think of those sort of as custom hooks. When you write custom hooks in React, you say use state. You almost always wrapping use state and then adding some additional logic. This is sort of the same way, right? When I set selected, I want to also trigger these other set effects. And then there down at the bottom, you can see this is also like, now I can just reach for my state with a normal method invocation. It's always up to date. It's always stored in the DOM. Safe, easy, it looks like OOP. Next, we have the targets API. One of the most annoying things in JavaScript is like actually selecting elements. Targets handles that. So here we can see another static declaration of targets, which includes an array of strings. This tells you what all your targets are called, and it creates a bunch of accessors for you. It will automatically update that list. You don't have to worry about stale references, right? If you start adding in new elements that have that target on them, they'll always be included in the list. And it also allows you to put lifecycle callbacks on those. I don't know if I think that's a good idea, but you can if you want. You can add custom code to run whenever an element is added. And then again, now I don't have to worry about query selector. I don't have to worry about figuring out where I stored the reference. I can just call this.template target, and I will always get my template element for when I want to insert that little like list box drop down into the page. And you can set this with the controller name dash target, and then values was controller name, value, value. And then finally, we have the actions API, right? This is our event listener management, all handled for us automatically. So they're always auto-registered. They're always unmounted whenever the element goes away. You don't have to worry about them. You can set them with data action. So for instance, on my list box, if I want to change the selected element when something in the list is selected, I would say click, list box, #, change. And that registers that event listener for you. And now I can organize all of those event listener callbacks as methods within my controller. And so just to give you an idea, this is all just Stimulus and Turbo. There's no React, there's no Vue, there's no Angular. This is just vanilla JavaScript. And I've got modals popping up. I have modals coming back from the server. I have keyboard accessibility, appropriate ARIA markup. I got, portals on top of portals. The stacking context works correctly, and I didn't have to write any front-end code for this. So where does this fall short? Funny enough, this was supposed to originally be the topic of this talk, but then I realized, like, with the time I have, I probably need to explain what it is first before talking about some of the shortcomings. But I've been really kind of limit testing this technique, both at work and at home over the past year, and I've come to the conclusion on a few things. Firstly, complex template management is obviously a nightmare. That's pretty obvious, right? When you start thinking of the way that you structure React components, where you can make different parts of your component appear depending on internal state, like, you can't do that. You can't, if you don't have a hydrated DOM, that's not something you can do. Now you can use like the native HTML template tags, but that's not gonna fly for complex state management. And so like a great example of this is a date picker. You can't put every single month in a template tag. That's psychotic. you need to probably reach for something like React for that, or a library, like if you want to use Flatpicker or something like that. The other thing is I had to write a portal implementation to make those like modals and stuff work. That was a nightmare because there's no shadow DOM, right? So now I have to relay events back and forth. That's crazy. I kind of regretted doing it, but there's more on this in a moment because actually this is more of a solved problem than it was when I started. Another thing that it struggles with is atypical form designs, right? Auto-saving forms are just annoying. You can do a couple things, right? You can do programmatic form submissions, or if you want to be like really fancy, you can just hide a button and programmatically click it. Both are not great solutions. It creates really weird user experiences because we can't really intercede when a form request is happening, where it becomes really difficult. Whereas with React components, we're able to drop our async await, notation on there and hold up before we do navigations. So auto-saving forms have some problems. Nested forms are also a nightmare. Form-encoded responses are great. I think they're super easy to parse out, especially when you already have a web framework like Rails that helps you with that. The problem comes in when you're like, well, I've got this thing nested 5 layers deep arbitrarily, so now I have to do tree traversal. It's like it becomes crazy. You don't get to flatten out the structure and just send it to the API like you would with React. So I'll tell you personally, anytime I'm writing a nested form in the future, I'm looking to mount React onto the page. And then the last thing is any insane wizard setup that's impractical to persist to the DB. I'm a big proponent of just persisting those intermediate results, right? It creates safety for you if you're going to do a multi-step form to write it to the DB. You don't risk data loss at that point. And you're probably going to do it anyway so that people can resume filling out the form. But not every wizard is compatible with that design. So if you need to like hold intermediate state on a complex form in the front end, you can't really do that very easily with this setup. And finally, applications that are like true applications. So think Miro, Canva, this sort of thing's not possible. It doesn't comply with the conventional web, right? We sort of had to contort the web spec to make those sorts of things possible, which is also why those companies make money. They wrote an incredibly complex application that you can't do with just web native tools. Now, I said I was gonna come back to this thing on portals. So when I began this, I began sort of noodling on this at home maybe last December. And I spent all this time like implementing vanilla JavaScript portals, and it was crazy because you have to worry about your stacking context and things like that. Well, right around the time I was wrapping this up, the Tailwind company released something really cool. They're calling it Tailwind Elements. These are all custom elements like turbo frames and streams that have all of this functionality built into it in an unstyled way that you can just drop in. It's like there's like a real first-class list box, stylable select in HTML. All you have to do is say L-listbox, and you get all of that behavior for free. And they did it using the popover and dialog elements. These have actually been supported by a majority of browsers for like 2 to 3 years now. They add true top layer support, so you don't have to simulate it with like React portals or vanilla JavaScript portals. And I kind of wrote them off because it's like a lot of the W3 spec stuff is kind of hard to work with. But the guys at Tailwind are amazing, and they made them work. And you can just drop them in, no JavaScript added. You get instantly accessible dialogues, list boxes, alerts, whatever you want. So yeah, that's my talk. We have found we are able to move a lot quicker when we stick to these one-person verticals, not separating UI from backend, being able to implement features all in one shot, not separating people across tech stacks. It served us well at Venn. It served me well on my personal projects. I'm a big believer in it. Has its limitations, but I know where to reach for it now. So hopefully I taught you all a little bit about that. Thank you for listening. I'm at Jacob Daddario on GitHub, Twitter. If you'd like any other contact info, please feel free to ask me. But thank you for coming.